Hey, welcome back to the Generative AI series by Microsoft and Growth Ecosystems. I'm Pablo Lopez, Global Cloud Advocate in Application Development and Artificial Intelligence teams. It is a pleasure to teach you about this amazing new platform and to deliver impact to everyone. Remember, this series is just the beginning. You can learn more on our website or start putting your idea to practice with Imagine Hub or grow it into a setup with Founders Hub. If you had an idea, Microsoft can help you make it to fruition. All the links are in the description below. But without the delay any longer, let's start using some generative AI today. Now, the first chapter, we introduce you some basics of generative AI. But remember, we're doing a startup, an education startup at that, with generative AI, and using this to implement new technology to our new company. How to explore this landscape is really difficult. You have a bunch of new terms like LLMs, tokens, etc. Don't worry, we are here to make it easy to everyone. But let's start to see how can we use LLMs and how can we make them suitable to our use cases. For this, we need to understand the different types of LLMs based on their architecture, training data, and use case. First, let's understand exactly how foundation models versus LLMs differ and how can we use them for our advantage. What is a foundation model? Foundation model was a term coined by Stanford professors and researchers, defining AI models with the same criteria. First, they need to be trained using unsupervised data or self-supervised data. It means that they do not require any classification or labeling of our data. Second, they need to be very large models. They can need to be based on very deep neural networks, and they had to have billions of parameters. Three, they need to be intended as foundation, which means that they can be used as base parts of new models, so it can train and make better and more specialist models. But what about LLMs? Well, LLMs are a type of foundation model because they can be used in a lot of small tasks like text summarization, translations. For instance, we can define meaning, answering, etc. This means that yes, LLMs can be foundation models, but this does not mean that all foundation models are LLMs. Imagine ChatGPT. ChatGPT uses GPT 3.5. This is a foundation model and is a LLM. But that would mean that all foundation models are language models. Now, let's think about open source modules and proprietary models. Open source modules are usually open to the public. It means that you can analyze. They have more permissive licensing, which means that you can analyze, take a look, you can customize a model, you can do a bunch of things with those new amazing models. However, usually they are the most funded models and can have older architectures. One of the examples would be Llama. But what about proprietary models? Usually they are maintained by companies. So it means that they are made available by some form. However, it does not mean usually that you can analyze it deeply. When sometimes you need some kind of subscription or payment to continue using, and usually you should entrust the company doing the model to maintain your data safely. One of the big examples of this private kind of models are OpenAI, especially GPT. Now great, you know of this, but you may imagine that you want to generate a lot of things, right? So first let's start with a more basic. Let's think about embeddings. Usually when I have an LLM, you need to pass the context to another LLM. You don't need to know about anything about context at this point, but it is important to understand that sometimes you want to have some data to pass to another model, and then you can process from that. These are embeddings. So sometimes you have models that just do that. Make prompts and create this number representation, this embedding. So this can pass to another LLM. So some examples we can use this is for surrogate models. Imagine that you want a model that wants to do another thing. We can process that to be a very specific model. Then you can use this as a surrogate model. Then they plug these embeddings, plug to that, and boom, you have some examples of how to use embeddings. But sometimes you want more than this. Imagine that you want to generate images, but you may think that that's their only use, that you can use images. But it's not only that. You can use, for instance, to translate in that image. You can edit this image. You can do in painting and a lot more. These are normally train a big data set of images. You can think about Lion 5B. You can as well generate new images, as well edit and do more things. These are amazing. For some instance, you can use DALL-E Free, which is available on Bing Chat or Stable Diffusion. Now we have the text ones. They are the text and code generation. So these are usually used for, you guess it, to generate text, complement, getting context, or maybe sometimes even writing more on the context that you already have. These are usually trained, as you guessed it, on for a big data set of textbook corpus, and you can use it like for code. For instance, you can get Parrot. So you often train these large data sets of images with code or text, and there is a very big data set of code for a GitHub Copilot, and you can generate new code which fixed boxes of the old one. Great, not a lot, but how does it exactly work? So imagine that you have a manager, right? And it gives you a task to write quests for students. You have two colleagues. One oversees creating content and other reviewing content. The content creator will be like a decoder. So he can look at the topic, see what already wrote it, and then he can create basically the quiz around that, right? So he can create, okay, what do I need to create with this? He can be very good at writing very engaging content. He can be amazing at it. However, we have an issue here. Sometimes he is not the best at understanding what he is doing. So sometimes they call only models, you can imagine like GPT-3. But sometimes they have the encoder-only model. He can review the course greatly, but has no creativity in how to write anything that he is doing. The reviewers like the encoder-only model. He can see the course and see if it's correct or not. He's not the best creative in writing it. So sometimes we have models like that to just verify and see, okay, this looks good. These can be models like BERT, Alberta, Roberta, etc. that can analyze and see if it makes sense, but it's not the best at creating those. So then I have both that can create and can review. We can have BART or T5, for example. Now we are having great progress, but how to make those available? Okay, so now you know everything about this. How can we use those? Very simple. You can use those on an available model and hardware. You can just use it deploying directly on the cloud or hardware. These are directly run by your company. They run locally or not, depending on cloud VMs, and you can scale dependently if you are on cloud or not if you are on hardware, which means that you have a lot of expenses. So, business, imagine like Falcon. You want to use Falcon. You need to probably deploy it somewhere. Services are normally very optimized for use because the model is already trained to be very optimal for that systems on the cloud. So normally you pay for them, pay a subscription or buy the number of user, and then boom, you have this ready to use. It can plug it in your service. Great. So imagine Azure OpenAI. Azure OpenAI goes by as pay as you go, which is amazing because you can have users be charged by proportionally by what they use, which is great. And you have as well enterprise services and enterprise security. Great. Now, congratulations, you know a lot about LLMs, but how can I implement that? Carlotta will tell you about it. Don't worry, I'll come back soon. But now, Carlotta, how can I deploy a service?
Sure, thanks Pablo. Hi everyone, I'm Carlotta Castelluccio, AI Cloud Advocate at Microsoft, and I'm happy to show you today how you can work with large foundation models in Azure. Why Azure? In the ever-evolving landscape of language foundation models, selecting the right candidate for your specific scenario is just the beginning of the journey. Once you have identified your top choices, let's say, it's time to put them to the test on your use case. Welcome to the world of Azure Machine Learning, your one-stop platform for managing the entire machine learning lifecycle. After extensive research, our startup has explored the current large language models landscape, and we have pinpointed some strong contenders for our unique scenario. Now the real fun begins. Testing these models involves an iterative process using experiments and precise measures to ensure they meet the mark. And where do we find these models? The Foundation Models catalog in the Azure Machine Learning Studio is your answer. Azure Machine Learning provides a seamless experience with a user-friendly interface. And here's what you can do. You can easily find the foundation model of your interest by filtering your search based on task, license, and name of the model. You can even import new models not yet in the catalog. But before you dive in, it's always a good idea to get to know your model. The model card provides a comprehensive view complete with detailed description and code samples. The sample inference widget provides you with the sample input to put the model to the test and get a taste of the results. To ensure your model aligns perfectly with your workload, evaluate its performance using objective metrics and your specific dataset. Sometimes a bit of fine-tuning is necessary. Azure Machine Learning empowers you to improve your model's performance with custom training data. Once your model is primed and ready, it's time to deploy it. Whether it's the original pre-trained model or your finely tuned version, Azure Machine Learning has you covered. It offers real-time inference or batch endpoint deployment, ensuring your applications can consume your model with ease. When it comes to deploy large language models into production, businesses have a world of options, each with its own set of complexities, cost, and quality levels. Let's dive into these approaches and see which one suits different requirements. The first approach is prompt engineering with context. Pre-trained large language models excel in handling general language tasks. You can simply feed them a short prompt, like a question or an incomplete sentence, and they work like a charm. We call this zero-shot learning. But here's the catch. The more context you provide, the better the large language model understands your request. When you include detailed examples and requests in your prompt, it's called one-shot learning for a single example and few-shot learning when using multiple examples. This approach is cost-effective and a great starting point. Approach number 2, retrieval-augmented generation. Large language models have their limitations. They only know what they were trained on and can't access post-training information or private data. To bridge this gap, we use retrieval-augmented generation. This technique adds external data in the form of chunk of documents into your prompt, effectively expanding the model's knowledge. It's powered by vector database tools like Azure Vector Search. And it is a valuable approach when you lack the data, the time, or the resources to fine-tune your large language model, but want to boost its performance and minimize risk of incorrect information or harmful content. Approach number 3, fine-tuned models. Fine-tuning is a process that customizes a large language model for a specific task. It generates a new model with updated weights and biases, making this approach ideal if your business prefers cost-effective and less powerful models, you have strict latency requirements, or you possess high-quality data and ground truth labels and you can maintain them over time. Last approach, train your own large language model. Training a large language model from scratch is a huge undertaking. demanding vast amounts of data, skilled professionals, and serious computational power. You'd consider this option only if you have a very domain-specific use case and an abundance of domain-centric data. In the world of large language model deployment, there's no one-size-fits-all solution. The right approach depends on your unique requirements, resources, and goal. Also, any choice we make about training and deployments, we should be conscious and transparent about models' limitations. And use responsibly practices and tools. In the next episode, you'll discover more about what these mean. Thank you everyone and see you at the next episode.